Okay, so let's just practice. So doing the same thing with the digit 2 and only with 3-digit integers. So 1, 2, 3, or 1, 2, 3, or 1, 2, 3. Okay, so if I put the 2 here, I have one choice for that. If I put the 2 here, one choice for that. And if I put the 2 here, one choice for that. Okay, so then if I'm putting in the rest of the digits, these two have 9 choices each because they're just not 2. I can have, I want to say it's not 2 or 0, so there's 8 choices here. And then this has to just be not 2, so there's 9 choices. And this one here, not 2 or 0, so 8. And then just not 2 here, so there's 9. Okay, so we've done lots of the same kind of problems. You're good to go. All right, so if I have a pin with 4 symbols, and we get to choose from 26 letters and 10 digits, and I can repeat. So each of the digits that I'm picking has 36 choices. So that gives me 36 to the 4th power. Okay, so I want digits and letters, but no repeats. So the first one I have 36 choices, then 35, then 34, and then 33. Okay, so if I want at least one repeat, this is a very huge thing you want to make sure you memorize. At least one repeat means take all of the cases, which is 36 to the 4th, and subtract off no repeats. And there you have it. That number is going to be all the ways you get at least one repeat. Okay, so then just adding on to that, what's the probability that it contains at least one repeat? Well, that's going to be your 36 to the 4th minus this divided by the whole, which is 36 to the 4th. All right, so we're going to make some telephone numbers here. So I need 7 digits. So 1, 2, 3, 4, 5, 6, 7. And does not have any repeats. So we go from the 10, 9, 8, 7, 6, 5, and 4. Okay, at least one repeat. Okay, so that's going to be 10 to the 7th because that's all of it. Subtract off. There you go. Okay, so no repeated digits, 1 through 999. Okay, so you have to be careful because you've got 3 kinds of integers. You've got 1 digit, you have 2 digit, and you have 3-digit integers. Okay, so how many 1-digit integers have no repeats? Well, there's 9 of them because it starts at 1, not 0. Okay, 2-digit integers. Okay, so I want to say for sure this cannot be 0, so there's 9 choices here. And then here, whatever I used here, I can't use here, so there's 9 times 9. Okay, so again, not 0 here, so I've got 9 choices here. I've used 1 digit, so I have 9 there and then 8. Okay, have at least, same problem, at least 1 repeated digit. So that's going to be all of the ways of 999 minus 1 plus 1, so that gives me 999 numbers total. So that's all, right? All subtract no repeats. And that's what we just did. Oops, plus 9 times 9 plus 9 times 9 times 8. Okay, so here we go. License plate has 0 to 3 letters, 0 to 4 digits. Okay, so let's see. I want to do the choices that I've got for the letters. Okay, so for letters, there's 1 way to have no letters, right? There's 26 ways to have 1 letter. There's 26 squared ways to have 2 letters. And then there's 26 cubed ways to have 3 letters. Okay, so that's letters and followed by 4 digits, right? So I've got 1 digit, no digits, right? So this is no digits here. 1 digit, and that'd be 10 choices. 2, 3, and 4. Okay, I am not allowed to have a blank plate. And this multiplied times this is no letter, and this is no digit. So I've got to take that one choice away. So I say subtract 1. Okay, so now we're going to look at multiples from 1 to 100. And we know that there's going to be an overlap. So we have to subtract the intersection. So the number of numbers 1 to 100 that are multiples of 4. So I think 4 times 1 all the way up to 4 times 25. So the number of multiples would be 25, subtract 1, and then add 1. So I have 25 multiples of 4. All right, so now I'm going to do multiples of 7. So I'll have 7 times 4. I'm sorry, 7 times 1, all the way to 7 times 14. And that gives me 14 minus 1 plus 1. So I see that there's 14 multiples of 7. Okay, so now what I have to find is the multiples of 28, because that's going to be in common. So I have 28 times 1, and I only can go to 28 times 3. So that means that there's 3 multiples of 28. So what I get for an answer is 25 plus 14 minus 3. So 36 multiples of 4 and 7, but after taking away the intersection. Okay, so let's just do a little bit different. 100 to 1,000. Okay, so if I'm going to do multiples of 100, multiples of, 3. Come on, eraser. Multiples of 3. Okay, from 100, right? So 3 times 33 is 99. So I know we're going to do 3 times 34 all the way up to, and I know 3 times 333 is 999. So I'll stop there. So I'm going to take these two numbers, right? So I'm going to take 333, subtract 34, and add 1. And that gives me 300. Okay, so now let's go to the next one. The multiples of 4. Oh, we just did that, but this time it's from 100 to 1,000. So the first one will be 4 times 25, and I'm going to go all the way to 4 times 250. Oh, silly me, 250. Because that gives me 1,000. Okay, so then I get 250 minus 25 plus 1, and so then that gives me 226. Okay, so now I need to find the multiples of 12 that I'm going to subtract, right? So the multiples of 12, so I'll have 12 times, I know 12 times 9 is 108, right? So that's over 100. And I'm going to go all the way to 12 times 83, because that gives me 996. Okay, so I'm going to take 83 minus 9 plus 1. So that gives me 73. That's what I'm going to subtract. So my answer will be 300 minus 226 plus 73. And I didn't figure what that is, but I'll let you.